Welcome back to another Fireside chat with the experts here at Creative Electron. Today I have with me Dr. Bill Cardoso and Carlos Valenzuela. So we're going to be talking today about the automated inspection of medical surgical kits. It's a project we've been working on and have some exciting results I'd like to talk about, especially in light of recent events with a lot of more kits and things like that being used in this field. So welcome, Carlos. Welcome back, Bill. Good to see you guys.
Good to be here.
So Carlos, maybe you can talk a little bit about what these surgical kits are, why they're important, why anyone would care about them.
That's a good start, right? So, these can be as complex and as simple. And we're not medical experts, but we've seen some that are some sort of surgical kit for some sort of surgery. And there's some simpler ones, maybe a COVID testing kit, or
Right.
a swab and little things here and there. But these are important because they do have key components inside of them, and most of the time they are not see-through. So they're either in a bag or a pouch or something like that. So that's where we get involved. And then that kind of simplifies how we got into it, and then why there was some interest in our technology for this industry.
Yeah, it's good to know that a lot of time medical devices, they have to be sterilized, right? So when the sterilization layer is for the most part opaque, so you can't really see what's inside. And that technique that Carlos is going to describe, it can be applied to any medical device or any sample, right? Where you need parts presence and placement to figure out where things are, right, Carlos?
Yeah, and that's one of the main kind of applications for machine vision are all the components present. That is one of the it's almost like machine vision 101. And in this case, we're looking at something a little more complex that might require a different set of tools, including X-ray. Because we've on some of our projects we combined optical with X-ray. For other stuff, maybe barcode scanning or things like that, OCR. But looking inside the object is the main reason. Looking inside this pouch that's been sterilized and not have to open it and make sure everything's there. That's kind of the main reason why we're starting to deploy this sort of systems and these sort of projects.
So in this case, manual inspection, as Bill brought up, is not an option, right? You have to open up these kits and make sure everything's there manually and then re-sterilize and reseal them. The cost is more or less not worth it, right?
I mean, your whole batch is compromised. So
yeah.
You open one.
You got to be sure the person opening it and checking it's not going to make a mistake, right?
That's true.
And get it sterilized again with missing something, right?
Yeah.
And something kind of interesting too here too is, we've seen a lot of some recalls and some things like that happen. When you use our technology or any sort of technology similar to ours, the idea is to protect yourself. So you're taking a picture of a kit that's been sterilized, and you have the image with all the components inside. So if for some reason somebody says, oh, this didn't have everything inside, you have the picture with the serial number, the date, the time, and all that. So who inspected it when. So that is also a big part of this. Get us getting involved as the process starts, or actually getting involved after something happens. So those are kind of the two important pieces too.
Yeah, with like a surgical kit, for example, if they're in the operating room, the cost per minute, I don't know what that would be, but it's got to be really high, right? So if you open up a kit and you realize, hey, doesn't have enough swabs, right? Even just something relatively cheap in that component. Now somebody's got to go get that second one. 5 minutes, 10 minutes, right? If somebody's under anesthesia, right? There's risk. There's all sorts of big problems. These things really have to arrive in perfect condition, right? Usable.
Yeah. And the traceability point is also critical, right, Carlos? So you can you can go back and check, even at different points of your manufacturing or packaging process, where things are, and potentially figure out what and where things went wrong, right?
Yeah.
Yeah.
And we like to get the call where people are setting up a process, right? And try to figure out where to use X-ray technology and this level of either machine vision or artificial intelligence to preempt these problems from happening. But we do have the calls where people have a warehouse full of gadgets, devices, samples, right? And they know that a few of them have been compromised. Now you have to inspect everything, 100, 200, 500,000 pieces of product to classify what's good and what's bad, right?
Yeah. Yeah, and that's a that's a good point. I think the inspection tools are becoming more important, not just X-ray, optical, any sort of inspection, because that kind of it's what closes the loop in your production line, right? If you're missing a syringe on your kit, 3% of the time, you have to go back to the syringe station and then see what's going on. Like, there's no other way to know it. There might be other processes, but creating this inspection tool that feeds back information into your production line, that's huge. So traceability and all that, it's becoming more important, and actually it's becoming easier to do with with our technology.
Right. Yeah, not just easier, but faster, right? What kind of speed? What kind of time does it take to do the analysis on something like this?
Just to put it in short terms, our machine is the probably the fastest thing in the process. Like, if you rely on a person to grab the bag from it, he's gonna be slower than our machine. We've taking an image takes maybe half a second. Processing it takes even less. So it's all about material handling. It's how fast can you put it inside the machine? How fast can you get it out? Does it some requires higher magnification, so you do have to stop for a brief second, take a picture. Some more simpler stuff doesn't even have to stop. More kind of what you see at the airport. And we've done things a lot with some fancy stuff with like conveyors. We've even gone into deploying robots and cobots outside the machine to grab bad product. So yeah, I think we've kind of hit that plateau where everything's so easy to deploy. Robots, and I think people in this industry are kind of used to it. So I think our technologies out there.
And that's why having the partnerships we have and to be system integrators for Fanuc and Dorner and all those material handling and movement companies helps a lot, so we can deliver a full solution, right? Not just a piece of it. We can really integrate a whole inspection cell instead of a piece of an inspection process, right?
Yeah, and this industry is very, very well defined. The automation that most of the companies we work with have, starting to have their own departments that are very familiar with our technology. Our robots, our conveyor, the communication protocols we use. So it's always becoming a very kind of seamless integration. We're not, X-ray machine used to be in this other room, that just had a sign that says X-ray inspection, and then you go in there and you X-ray. Now it's not. Now it's part of a process. Like, we can be after maybe a machine seals the bag or seals the box. We can be right after that and basically be seamless in your process.
Yeah, and part of that too is explaining the safety aspects to a customer, right? Whereas you used to kind of hide it in a corner or put it in a separate room for safety. Maybe it wasn't necessary, but just kind of this thought that people would have. But the cabinets we make, FDA has very clear guidelines about safety around it, right? We're very comfortable with those, handle that. and it's not a concern. So you can put it on the line with people all around it, and they're not going to be under any kind of safety concerns or unsafe conditions, right?
Yeah, and that's where our expertise comes using, right? To design a system that's safe, right?
Yeah.
With interlocks and the proper amount of shielding. So, you can have it operating in any environment that's needed. And those are 2 questions we get often, right? It's about safety of the equipment itself, and if X-rays are going to damage your product. And the question, so safety, that's our expertise. That's what we do for a living, right? So we design machines and design systems to make sure that it's fully safe and complies with all FDA and CE requirements.
Yeah.
And then we have if X-rays damage the product, and the answer is no, right? I mean, I've been doing this for a long time, and I haven't found a case where our X-ray, as Carlos said, is very fast. So the level of exposure is very low, very small. And you got to keep in mind that the product you're manufacturing, you're packaging, is going to be shipped somewhere, right? And other shipping companies have X-ray inspection systems that are much more powerful than the ones that we use for this level of inspection, right? I'm talking about airports, shipping companies, border control, right? They all have very powerful X-ray machines to go through containers and bags and pallets, right? So the level of exposure that we usually offer to the sample is very, very small and is fast. So it's safe from both radiation exposure perspective and potential damage to the sample.
And and some of them do also go through some sort of X-ray sterilization process.
Yeah,
that is a lot higher than what we do. So X-ray is not really going to damage product. And most of the in this case, talking about kits, these are plastic pieces. They're thin pieces, so they're going to require the lowest power essentially that we can do. We do higher power for metals and castings and things like that, but a medical kit is really going to require very low power. That's not going to make a difference.
And again, for the people commenting on this video on YouTube, I just want to make sure that we're not saying that radiation doesn't damage plastic and other materials, right? That's not what we're saying. But we do know that radiation is all about the time of exposure, the distance between the source and the sample, and the power of the X-ray source, right? So the 3 things combined give you the level of potential damage that radiation is going to have in the sample. And we do very low power and very fast. So we do minimize the amount of radiation that the sample is exposed to.
Right.
All right, keep an eye out for those commenters, man. They're smart.
Catch them early.
Yeah.
Preempt.
Yeah. So, Carlos, you mentioned, I think you brought some images of a kit we were working on.
Yeah.
Correct? You can share those so we can take a look at them.
Cool. Show and tell today. Nice.
That's right.
Can you guys see that image?
Oh, it's beautiful. Yeah.
Okay.
What are we looking at?
So this is it's a medical kit. Of course, we talked about it, right? It's a I probably forgot already, but it's a project that we've been working on, and it kind of has a combination of a lot of things that we've been discussing. It's a combination of needles, tubing, there's a scalpel there, different components that they can, move around the kit itself. I don't have a picture of the package itself, because there's, the NDA is protecting this and all that. But basically, you can't see through this object. It's a white bag. Even with the most powerful backlight, there's no way that you can see it. With good results. You might be able to see some stuff, but once you get on a different angle, then everything gets really complicated. So I mean, you can see here how clear the image looks. You can see, as components shift around it, you can know exactly where they're at. And there's two levels of what we do here, or what we can do here, depending on what the client needs. Is location important? Do you have, do they have to be on the same location every single time? Like, is a doctor almost closing their eyes and just, grabbing it, or, something like that? Or do we just need a complete kit? Are they going to be open and they just put on a shelf, or something like that? So, so this is where kind of our vision tools come in. Do we create a search region for the component? I can see here, like this one, the 3 vials in the middle are on top of each other. Is that okay? We can locate the 3 vials there, and we can know their location, but does this merit a filled product? So, it can be complex. I can see the device here. This one moved, even though it's still a complete kit, they're kind of moving around. So that's where we kind of work with a customer, and what is their requirement. Of course, if this is normal throughout the process or through shipping or something, you don't want to be failing, a lot. So if this is normal, normal in your process, then we can accommodate for that.
Right. So is that, you mentioned using machine vision as kind of inspection 101 to see if things are where they're supposed to be. Is that the difference here with that versus using artificial intelligence, for example?
Yeah, and that's a good question. I think there's always there's a fine line of when to use the right tools. Now machine vision it's pretty powerful with pattern recognition and location, and orientation. All that doesn't matter,
Right.
but there's limits to it. There's limits to what that can do, and then that's when we look at artificial intelligence or deep learning. Just a system working with through some a database and some feedback. If you look on the right side, there's like this tubing here. That is okay on many different locations and orientations, and that's where maybe a deep learning would help for this type of inspection. If it's flipped or if it's coiled a little bit different, the system can start to learn, what it's going to look like. And then sometimes X-rays can kind of vary in grayness a little bit. So the deep learning approach gives us that flexibility to find things, even if they got darker, or there's a without getting too technical into X-rays, there's an effect called parallax. So things might look different in different locations. So they might portray like a different shadow. So using a deep learning approach where you're feeding it information, the system is gonna give us better results. So you're telling the system, okay, this needle looks like this at this corner. It looks like this at this other corner, and flipped. So it starts to understand, what it looks like and what it's looking for to give us better results. But to kind of summarize, our first approach is always try to do this with machine vision. I think it's an easier path to the project. And if we hit a wall, then we start deploying our other more complicated tools.
Yeah, I think for this project specifically, the boundary between machine vision and AI is, if you're just looking to make sure that that needle is in the right pocket, right? If it's there or not, we can set up a region of interest, and with machine vision, we can figure out if the needle is there, right?
Yeah.
Now, if that's the question, it's a machine vision path and pretty straightforward. We're pretty much done. Now, if the question is, is that needle in that package, anywhere in the package, right? That became a much more complicated, exponentially more complicated problem that machine vision can't answer. Especially if the needle is going to overlap with the tubing or is going to be on top of the syringe. That becomes a very complicated problem that, again, machine vision can't answer. And that's where we deploy artificial intelligence, right? Artificial intelligence, we can train what a needle looks like, right? And we can tell it, we can train AI to find a needle at different positions of the tray. And over time, and with more samples, as we look at more images, AI does a pretty good job finding the needle in the haystack, if you will. So it's difference between the well-conceived problem that machine vision can answer and the ill-conceived problem, which is what AI looks for, right? AI is ill-conceived. You can't really describe in a set of rules exactly what is the problem that you're trying to solve. Yeah, so that's what the boundary is, and this project is very clear. Depending on what the client's looking for, we can deploy either machine vision or artificial intelligence. But the cool thing is that we can do both, right? And we can solve the problem no matter what the extent of detail that the client's looking for.
Yeah, and even combine both technologies in one same solution.
Yeah.
Here, and because this is kind of like the beauty and the problem. I don't want to call it a problem, but what X-ray gives us, if you look at the current image, you have some, a needle and vials on top of each other, and in an optical world, the product that's on the top, that's the one that you're going to be seeing.
Yeah.
But in X-rays, you're seeing all of them. So, so a pattern match, pattern algorithm wouldn't work because the object's actually now a new object because you have two on top of each other.
Overlapping them.
Yeah. So this is kind of where, that line that, Bill was describing is giving the system the flexibility to be able to be matched at different, with different configurations or with different type of use. You have one on top of each other, you're still going to find it. So that, kind of describes, but in this application, X-ray becomes, a very, very powerful tool.
Yeah. And it goes to the process we use, right, to solve those problems. We don't come to the problem with a solution and we try to fit solution to the problem, right? We first start with a proper description of what the project is and what are the boundary constraints that we're trying to achieve. And then we develop a solution to meet those constraints, right?
Yeah. And we do, we do what we call, a feasibility study. That's, it's customers reach out to us for a solution, and sometimes we don't know if we have it right. We've had experience, and sometimes we know right away if it's a good match or not. But doing a study like this is gonna allow give give the customer or the who's ever reaching out to us the confidence to move forward with a solution. So I think that's a good point.
Yeah, those feasibility studies can be real critical. Remember, Carlos, we were working on a project. They were looking for like 27 different plastic parts in this one thing, their widget that they made. They wanted to make sure, verify that all 27 of them were in there. But they're all the same kind of plastic, right? So we did quite a bit of work with them, different angles of inspection and hey, what can we see? What can't we see? What should you just use optical inspection for, right?
Yeah.
X-ray is not always the answer, and we don't want to be pushing someone into, that box. Like Bill said, we're not pushing people into a solution that we have just because we have it. Let's find the best one for the customer. So that was a really interesting project from the feasibility study stage of finding out, yeah, you can see this. Oh, and that's not there, then, maybe you can't see that one particular part, but you can tell that all this other stuff was changed because the thing wasn't in there. So,
yeah, addition by subtraction or something, right?
Yeah.
If this is not there, then we don't even have to look for other things. And it's a good, that was a good project to kind of start, deploying also, with our experience with machine vision and AI, start also looking into, even though X-ray is our expertise and that's what we do 100% of the time, start to involve other technologies, optical inspection, and just kind of blend them into the same solution.
Exactly.
Maybe we could see 15 different plastics and components on one device, and we couldn't see the next one, but just putting a camera on the top was able to give us that view. So those are the things that we're starting to blend, that we blend together to give a better solution to the customer.
Yeah, which is, by the way, nice setup, Carlos, because that's the topic of our next Fireside chat, which is data fusion. So how you can combine different imaging modalities, right, to come up with a full solution that's actually better than the single modalities alone.
Cool. And that wasn't on purpose.
That's good. Give them a taste for next time. So, we can wrap it up here. As Bill mentioned, we'll be meeting again in 2 weeks to discuss data fusion. So, look forward to that. And if you have any questions for us, as always, please leave a comment on our YouTube channel, and we'll get back to you as soon as we can. Thanks, Bill. Really appreciate your time. And thank you, Carlos. Always good chatting with you.
No problem.
Thanks, guys. See you later.
Have a good day.